All right, today we're going to start a brand new unit. This is Unit 4. It is called Congruent Triangles. And we are going to learn all about triangles in this unit, but we are going to focus on more proofs. But I think you'll find that the proofs actually get much easier, and all the hard work you've put into working on theorems and postulates will really pay off. Okay, let's get to that first section. Section 4.1, Applied Triangle Sum Properties. So we are going to go through some vocabulary and learn, you can see below, we've got two theorems and a corollary, and solve a couple problems. Okay, let's review these classifications that I believe you probably have studied previously. So the first one, what I want to do actually is label across the top and define across the bottom. So this first one I'm going to label as acute. Let me just go ahead and label what the vocabulary word is, and then let's define it. So the first one we will call acute. The second one that has these three arcs on it is called equiangular. It's E-Q-U-I-A-N-G-U-L-A-R, equiangular. This one, the third one over, I'm sure you're familiar with. It is a right triangle. It's got one right angle. And the last one is obtuse. Okay, so definition. Acute angles or acute classification is a triangle with three acute angles. I'll use the angle symbol there. So if all three angles are less than 90, we call that an acute triangle. Equiangular, you can tell with the arcs here, it has three congruent angles. And actually, if we take this one step further, if you know all three angles are the same measure and all three angles add up to 180, well then 180 divided by 3 is 60, so all three angles have to be 60 degrees. Okay, a right triangle has one right angle, one right angle. Okay, and then an obtuse triangle has one obtuse angle. Okay, so we have three acute angles, three congruent angles, one right angle, and one obtuse angle. So these words right here are the vocabulary words that we will use when asked to classify triangles by angle measures. Okay, let's classify by side lengths. So we have, the first one is showing three congruent sides. So it is called equilateral. So E-Q-U-I-L-A-T-E-R-A-L. And so underneath, let's go ahead and define as we go. It has three congruent sides. So think about the word lateral means side. So three congruent sides is equilateral. The second one has two congruent sides. That is called isosceles. Isosceles and definition. Now I'm going to add here not just two congruent sides, it's at least two congruent sides. So I guess theoretically, if it had three congruent sides, it could be classified as isosceles, but we tend to just classify two isosceles and three is equilateral. Okay, my third picture over is showing no congruent sides, and that is scalene. So no congruent sides. Okay, so if we were classifying by side lengths, I would use these three words: equilateral, isosceles, and scalene. And very often, when we do triangle classifications, we classify by both angle measure and side measure, so we would say both. Okay, let's move down to these theorems. The first one is called the triangle sum theorem, and many of you probably know this theorem already. I highlighted the name because it will occasionally show up in a proof. So it's good to know the name of it in case you need to quote it on the reason side. But the triangle sum theorem says the sum of the measures of the interior angles of a triangle is 180. So if you look at this picture over here, the measure of angle A plus the measure of angle B plus the measure of angle C is always going to add up to 180. And a lot of you have probably learned that in the past. Okay, the next one, though, is probably going to be new to you. It's called the exterior angle theorem. So let me read the theorem, the wording of the theorem, and throw some numbers on this picture and go through it. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Now, first of all, I want to point out that an exterior angle is here, angle 1. So if you were to take a triangle, and if we were to take the sides of any side of a triangle and extend it out, we can create an exterior angle. Okay, and I can kind of do that everywhere. I can take this side and extend it out, and I have just created an exterior angle. I can take this side, extend it out, I have created an exterior angle. Okay, so the exterior angle is just on the outside of one of the interior angles. This theorem says that the measure of this angle right here is equal to the sum. Okay, so I'm going to add together the measures of the two non-adjacent interior angles. So this angle right here is adjacent to 1. Okay, that's not the one we're talking about. We're talking about the non-adjacent angles. So we're talking about angle B and angle A. So if you were to take the measure of angle B and angle A and add them together, it's going to equal the measure of angle 1. Okay, so let's say that angle B, is 80. I'm just sort of making numbers up here. And measure of angle A is 40. Well, angle 1 is going to be 120. And sometimes we can figure this out with the theorem above, triangle sum. So if I were to figure out this third angle right here in a triangle, we know all three angles add up to 180. So if I were to take 80 and 40, which is 120, and if I were to take that away from 180, I get 60. Let me change my color here so it shows up. Well, these two angles here are a linear pair. So if I take 60 away from 180, I'm back to 120. Okay. Now we don't always know the 80 and the 20 or 80 and the 40, so we have to trust this rule if let's say we're given all variables. Okay, our third one is called a corollary, and we haven't had a corollary yet. It's actually a theorem, but it's one of those things where it's like an extension of a theorem. And you can very often get to this corollary without actually using this rule. So it just says that the acute angles of a right triangle are complementary. So if you think about this, if this is 90, and I know that all three of these angles have to add up to 180, well, if I've already taken up 90 of the 180 over here with angle C, then I'm left with 90 between these two angles B and A. And so therefore, if these two angles A and B have to add up to 90, well, that means they're complementary. So the corollary is kind of like I said, an extension. It's something that is kind of like, well, yeah, I guess that makes sense. But we don't necessarily need to always use it to get to the final answer. A lot of times we can go back to triangle sum theorem. Okay, let's run through a few examples here. I would encourage you as you work through problems, I want you to think about what theorem you are using. Because if you can think about what theorem you're using, the more you practice the names of the theorems, when you have to quote them in a proof, you're going to have those names down. Okay, classify the triangle by its angles and sides. I'd actually like you to pause the video and try this on your own. So when it says angles and sides, you need to use one of the 4 words for angles and one of the 3 words for sides. Okay, so this is just a vocabulary recognition question. So I'd like you to pause and then come back when you have your classifications. Okay, by angles, I see an obtuse angle. So by angles, this is an obtuse. And then if I look at side lengths, 19, 23, and 8 are all different. And that is a scalene triangle. So this is an obtuse scalene triangle. Okay, by angles, I see a right angle. So this is a right triangle. And then by side lengths, okay, I see the two 4s. 4 square root of 2 is not the same as 4. So this has two congruent sides, and so this is isosceles. So this is a right isosceles triangle. Okay, let's find the measure of the requested angles. Okay, I need to find the measure of BCD, ABC, and BCA. So let me start here, BCD. So B down to C over to D. So this angle on the outside is BCD. So this is an exterior angle. So I'm going to use the exterior angles theorem. It says that the exterior angle is equal to the sum of the two non-adjacent interior. So I'm going to be able to say that this exterior angle is equal to the sum of the two interior angles. So I'm going to say 76 plus 2x is equal to 5x minus 2. Okay, that's the exterior angles theorem. Okay, from here we solve. So I guess I will take away 2x first. Doesn't really matter if you do this step first or second. All right, 76 equals 3x minus 2. I'm going to add over my 2. So that gives me 78. Divide off your 3. And so 78 divided by 3 is 26. Okay, so now I really want the angle measure. So I'm going to plug it into that angle. So I'm going to do 5 times 26 minus 2. So 5 times 26 minus 2 is 128 degrees. So I've got that the measure of angle BCD is equal to 128 degrees. Okay, ABC. ABC is this angle up here. So now that I know x, I can just plug it in. So 26 times 2 is 52. So the measure of angle ABC, 52 degrees. And then BCA, okay, BC over to A. So that's this angle right here with nothing on it. So I could go about this a couple of ways. I could focus on the interior of the triangle, and all three angles add to 180, and I know one of them is 76 and the other's 52. Or I could focus on, let me switch my colors here. How many colors can I get on this picture? I could focus on these two angles. They're a linear pair. They're supplementary. So if I already know that the outside angle is 128, if I take that away from 180, I will have the orange angle that I want. So when I do that, I get 52. All right, so the measure of angle BCA is also 52 degrees. So if I had to classify that triangle, I would know it's isosceles. I guess I'd call it, what, an acute isosceles triangle. Okay, I'd like you guys to do this last example, number 6. So will you please stop the video and work through it and then come on back and I'll talk about, I guess, also what the answer is and what the theorem that goes with it is. Okay, I need BCA and BAC and BCA. Two ways to do this to solve for x first. I could focus on triangle sum. Okay, I could say that all three angles add to 180. So what I could do, option 1, is to just add them all up. Plus 90 equals 180. Okay, or, and I could solve it and that's great. Or I can use this corollary. The corollary says that these two angles are complementary. Or what I could do is say that 3x plus 11 plus 4x minus 5 is equal to 90. So can you see that the corollary basically takes this 90 and subtracts it from 180 to give me the 90 here? So that's why it's really like an extension of the theorem. However you work it, we'll get the same answer. I'll just continue this equation right here. So 7x plus 6 is equal to 90. Take away 6. That is 84. And then if I divide off 7, I get 12. But I need the angles. So BCA, so it's these two angles, I believe. There's BCA. I keep doing this one first. This is BCA. And then BAC is down here. Okay, so I'll start with that one since it comes first in the problem. Measure of BAC, so just plug in 12. So I'll do 3 times 12 plus 11, and I get 47 degrees. And then the other one is BCA. And I'll go ahead and plug it into the expression. That way I know I did my math right in my equation. 4 times 12 minus 5 is 43. Okay, and those are my two angle measures. All right, well that is it for this very first section. If you have any questions, feel free to reach out via email and feel free to